Good afternoon. My name is Fernanda Molina. I will present the main concept of this paper named Design Principles for Constructing GDPR-compliant Blockchain Solutions. We created this paper together with Gustavo Betarte and Carlos Luna as part of a master's degree in the Computer Institute of Universidad de la República, Montevideo, Uruguay. Blockchain is an incipient technology that offers several advantages over traditional systems such as decentralization, transparency, and traceability. This technology, though, has some general weaknesses concerning scalability and performance issues, but most importantly, in our view, regarding confidentiality, immutability, and access control. These weaknesses make blockchain can hardly address the data protection requirements defined by the General Data Protection Regulation (GDPR). In this paper, we analyze the GDPR and the weaknesses and strengths of blockchain, study the integration of off-chain capabilities in blockchain-based solutions, and finally propose a methodological framework combining blockchain and off-chain. First, we will introduce some concepts about blockchain and off-chain technology. Blockchain security relies on public key cryptography for identifying transactions and hash technology to provide guarantees of the immutability of the chain. Additionally, blockchain architecture ensures integrity, immutability, and traceability by design. However, since all transactions must be validated and processed by all the nodes of the network, all the information necessary to perform this processing must be public, generating information confidentiality problems. Additionally, immutability could be a problem in systems that require erasure or alteration of data, which is one of the GDPR requirements. In some circumstances, it may be desirable to move data or computational operations outside the blockchain. This storage or external processing is called off-chain processes. The incorporation of off-chain processes into a blockchain-based system may introduce some problems of integrity and availability of data. As we saw before, in a blockchain solutions, integrity is guaranteed by default, because by design it is impossible to modify data without being noticed by the rest of the network. However, when storing data outside the blockchain, this feature is lost, since a third party becomes responsible of handling the storage. Therefore, a verification process must be required to ensure the integrity of the stored information. As to availability, when data is stored outside the blockchain, this property is difficult to guarantee, since there is a single point of failure. Thus, decentralized and redundant solutions must be evaluated. Finally, off-chain solutions do not define by design audit processes, so auxiliary mechanisms must be considered in order to register an audit trail of the access and change made. On the other hand, off-chains can provide confidentiality and the possibility to delete or modify information. In this paper, we have carried out the analysis of the General Data Protection Regulation that allow us to identify and classify the weaknesses and strengths of solutions built using blockchain technology concerning the security and privacy requirements established by that regulation. In this table are described the blockchain and off-chain functionality components that, combined, could make it possible to design a solution satisfying data protection requirements, like responsibility, confidentiality, access control, the right of access to personal data, delete or modification of personal data, integrity, traceability, transparency, and availability. Given a data security or privacy property, we point out the behavior that can be or cannot be guaranteed by a blockchain and off-chain mechanism. Associated with the property, we also make explicit the basis that shall constitute the methodological reference to build the high-level system architecture of hybrid models. Details can be seen in the paper. One of the points we want to comment are referred to the use of keys and hashes in blockchain. Blockchain uses a public-private key system to identify the owners and recipients of transactions. Therefore, according to the GDPR, these keys should be treated as personal data, that is, as an identifier of a person. But public keys cannot be obfuscated or deleted since they are used to identify transactions, so mechanisms should be adopted in order to avoid traceability. For example, the use of a new pair of keys for each transaction would make more difficult for key to be linked to a common owner. An alternative approach based on the use of decentralized digital identities to protect the identity of the data of users are the tools provided by Hyperledger Indy. On the other hand, hashes value are used in blockchain as a way to preserve the integrity of stored data. Hashes are considered pseudonymized information, not anonymization, because it is still possible to obtain the original data, so although pseudonymization is important for risk minimization, they are in the scope of the GDPR. The use of a hash function may leave traces that can be used to discover information by the application of well-known patterns analysis techniques. This is known as bonding. The risk of bonding increases if simple information is saved, because the output of a hash function can be guessed from a known input. Therefore, it is advisable to use different techniques to reduce the probability of obtaining the input value, like the use of a salt in the hash. We now proceed to describe the methodological framework that can be used to specify the behavior and services of a solution that integrates blockchain and off-chain functionalities. From the analysis carried out, we can conclude that we must use an off-chain to store personal data, while blockchain technology could be used to build embedded in the system an access control network, an audit network, and an integrity network. The first one stores the access control policy and, upon request, performs the corresponding authentication and authorization validations. The audit network records all transactions that have been performed, such as authorization, access request, modification, and deletion of data. The immutability of blockchain provides an appropriate settings for recording audit logs. The integrity network is responsible to validate data stored off-chain. When a data is stored in the off-chain network, a link can be stored in the blockchain network so that it is possible to locate the data. Together with this information, it can be stored in an integrity control check mechanism, for instance, using a hash function. Complementing those three networks, we use a gateway for external communication with the blockchain and the off-chain network. As authorization mechanism, we use a security token service. Our model consists of 8 use cases that cover the principal services we understand can be used to build a blockchain and off-chain based systems complying with well-established security and privacy requirements. We will analyze more in depth the data access use case. In order for a user to access personal data stored in the off-chain, first he has to obtain the authorization token from the access control network. When attempting to access data, the user is required to provide that token to the off-chain, which in turn shall validate by the access control network, and finally send the data to the user. All these accesses are stored in turn in the blockchain audit network. Some implementation considerations we recommend are: whenever is possible, use a permissioned blockchain. Use an off-chain with commit chain architecture. Use hash values computed from the data as integrity control and validation mechanism, but consider introduce random elements that take into account the identifier linked to a hash. Finally, use certificates and public key to identify the actors of the systems. About conclusions and further works, the architecture and characteristics of blockchain have consequences of how personal data is stored and processed. So one conclusion we make from the analysis we have developed is that complementary mechanisms are needed for those solutions to be GDPR compliant. We propose the use of off-chain mechanisms to design and implement hybrid blockchain systems with capabilities to enforce access control to personal data and to guarantee the confidentiality of the data management by the system. In order to assess the adequacy of the frameworks, we are currently working on the implementation of a prototype of a system that provides services to handle, store, and validate academic digital certificates. An interesting challenge is the conception of the mechanism to register and authenticate the third parties that shall interact with the digital certificate system using a decentralized solutions. Thank you very much.
Okay. Hello, everyone, and welcome to the afternoon session of WebSeb 2021. Here we are with Maria Fernanda Molina, who has been the speaker for the last talk, the first talk in the evening regarding the GDPR constraint and blockchain technology. And as you already probably know, the system cuts the video after exactly 10 minutes. So Fernanda is going to be here first to resume conclusion and results of their work, and then to answer your questions. Please write down your questions into the page chat. I'll send a message again to all of you. So please use the chat for the message. Maria Fernanda, please, the stage is yours.
Okay.
You can share the slides, yes, conclusions and results. And then we start with answer the questions and answers.
Okay. For conclusions, the architectures and characteristics of blockchain have consequences on how personal data is stored and processed. So one conclusion we make from the analysis we have developed is that complementary mechanisms are needed for those solutions to be GDPR compliant. We propose the use of offchain mechanisms to design and implement hybrid blockchain systems with capabilities to enforce access controls to personal data and to guarantee the confidentiality of the data management by the system. In order to assess the adequacy of the framework, we are currently working with colleagues Uruguayan University on the implementation of a prototype of a system that provides service to handle, store, and validate academic digital certificates. An interesting challenge is the conception of mechanisms to register the third parties like employers that shall interact with the digital certificates system using a decentralized solutions. And that's all. Thank you. You are muted.
You are muted, Roberto.
About that. Hello. Thank you very much, Fernanda. Yes, I was speaking along. Okay, so please, everyone is welcome for questions. Please write down the question into the area for the page chat. Okay, in any case, I have a question for you, Fernanda. Actually, your talk has been quite general, so you didn't pick up a specific blockchain technology, because actually the problem is a general problem. That's correct. But I'd like to ask you first if you tried to set up a specific blockchain technology to implement your scheme, and then if you consider that your scheme can implement it also on different blockchain in general.
In the proof of concept, we now are studying different technologies. Probably we will work in Hyperledger Indy. But the studies is more general, yes. We will use a private blockchain to be GDPR compliant, and probably Hyperledger Indy.
Oh, okay, but okay, you didn't use it yet. Oh,
no.
Oh, you. Oh, okay. And do you think it can be applied? I mean, your procedure, your scheme can be applied also to other blockchain, like, I don't know, the Ethereum, maybe Hyperledger Besu or something like that, for private blockchain, of course.
Yes, there are some implementation now for academic certificates implemented in Ethereum, for example. There are in Brazil and Argentina, they are working with it.
Okay. Then I'd like also to know a bit better how does it work, the token that is provided for the access control network. You,
Yes.
I mean, in the video mentioned a token that can be provided for the access control network.
I don't understand your question, sorry.
In the video,
Yes.
you mentioned a token that can be provided for access the data. How does it work? I mean, who can ask for the token? Who can be provided with the token to get access to the data? With which kind of policies are okay?
The policy access network in the blockchain will provide a token, so you can send this to the off-chain, and the off-chain validates that the person has the authorization to access to the data, asking for to the blockchain to the token.
Okay, but there is a specific actor in charge of providing the token, a regulatory body, or
the policy access network in the blockchain is the component that validates the authorization and send the token to the gateway. So the gateway then send the token to the off-chain.
Okay. Okay, there are no questions from the audience. Okay, I have another one. Since you can backtrace specific addresses and link between addresses, you mentioned a bit about that. And you can, in a way, sort of reconstruct the link between addresses so that to a certain level, in general, on a blockchain structure, you're able to identify if different addresses belong to the same owner. And did you imagine a scheme how to solve also this kind of problem?
We didn't work for this yet.
Okay. You mentioned that you suggest to use a new address for any new activity, something like that. Okay, that can be a part.
Another probably is to use decentralized digital identities. So we are studying the hyperledger leader for that reason.
Yeah, okay. Maybe the self-sovereign identity concept or decentralized identities can solve this kind of issue with privacy and stuff. So that you can expose also on the blockchain just a few information on yourself and on your data. Okay. Yeah, it's strange because usually at this point I will ask the people to thank again the speaker, but that's not the live session. I don't know if, yes, we can do something like with emoticons. Let's thank again Fernanda, and we are almost ready.
Thank you very much.
Okay, thank you, Fernanda, for your talk, and we managed it. So in about 50 seconds, we are going to be redirected into the next talk live, and then we'll be again back on the backstage with the next speaker for answering questions. Thank you again, Fernanda.
Thank you.
Thank you very much.
Okay. Next one should be opportunity and challenges of blockchain-oriented systems in the tourism industry. live in 4 seconds.
In our